All right, I just want to move ahead just a bit, skipping a little bit of some boring stuff as it relates to measures of dispersion. I think I'll come back and talk about that um, at a later point, but I want to get to talking about describing relationships between variables. So I want to start at slide number 35, which looks like this on the board. All right, so once we finish thinking about how to describe data, it's important that we understand that that's just really the first step. The real action is figuring out how to talk about relationships between variables, how to talk about a relationship between an independent variable and a dependent variable. That's where all the fun begins. Now, really, thinking about this relationship between variables really requires a deep understanding of probability and significance testing, but we don't have time for that, right? I just need to cut to the chase and show you guys how to think about the relationships between variables and how to do this. And then you can invite me back another time and then we can go deeper into talking about probability if you want to, but I really think that you don't necessarily need to understand that. Again, this is me just giving you tools for communicating with your stats consultant, okay? But before we begin thinking about relationships, it's really important for us, right, to understand what it is we're doing, right? So the first tool that we'll talk about for assessing relationships between variables, again, relationships between an independent variable and a dependent variable, is to think first about what it is we are up to, right? So I want us to now go back, step back to the beginning of our time together today and talking about, right, this thing called an independent variable and a dependent variable, X and Y. Once more, when we talk about relationships, graphically, we're talking about relationships that flow from left to right, where X is the independent variable and Y is the dependent variable. Our goal is to establish a conceptual model of a relationship and find evidence to support it. Now, that is a mouthful. Remember I said that one of the early things we need to do is we really need to think about what our story is, right? What is the conceptual relationship that we want to figure out from the medical literature, okay? Once you figure out that conceptual relationship, that's what I mean by a conceptual model. What is the conceptual story that we want to tell? And this is important. Your conceptual model must match the statistical model that you use. The conceptual model goes hand in hand with the statistical model. Literally, the conceptual model, the story you want to tell, is married to one flesh with, using a biblical term there, the model, the statistical model that you use. They go hand in hand. They are literally married, okay? But let's actually put some meat on the bones of exactly what I'm talking about. When I talk about this business of independent variables and dependent variables, I want to define what I mean by that. An independent variable is often called an explanatory variable, a variable that explains something else, okay? How does high blood pressure relate to hospital stay? Hospital stay is the dependent variable. High blood or measures in blood pressure is the independent variable. How are they related one to another? So the dependent variable is the variable that is explained. The independent variable is the variable that explains, okay? The independent variable often is always referred to as the X variable, and the dependent variable is always referred to as the Y variable, okay? You want to assess whether there is evidence for a relationship between X, the independent variable, and Y, the dependent variable. Okay, now again, this thing called X and Y must have a story behind it. You have to have a reason for why there should be a relationship between X and Y. And that relationship then is confirmed statistically by the model, the statistical model that you have. Again, confirmed by the statistical model. Okay? Now, it's all really doing this, confirming this relationship is all about measurement. In quantitative research, the tool that is used to find evidence of the relationship between the independent variable and the dependent variable depends on two things. One, how the independent variable is measured, and two, how the dependent variable is measured. We're going to start this conversation pretending that we want to figure out a relationship between a quantitative dependent variable and a qualitative independent variable. A quantitative dependent variable and a qualitative independent variable. And here is what we want to figure out. Is there a relationship between gender and the age at which people initiate sexual contact? Let's call that concept sexual initiation. And again, is there a relationship between gender and sexual initiation? Here's a question for you. What is the independent variable? You said gender. Why do you think it's gender? That's not a statistical question, it's a conceptual one. Why should gender be the independent variable? It's consistent. In other words, what you really mean is that it's something that you're born with that doesn't change. Correct. That means that sexual initiation is the dependent variable, right? Here's a different question for the audience. Why do you think there should be a relationship between gender and sexual initiation? Why should there be one? What is the story behind that? And that's an epidemiological or medical question. What do you think?
There's sexual biological, there's sexual differences.
Mm-hmm. Yes. Yes.
May affect sexual behavior.
All right. What do you think the relationship should be? In other words, who should initiate sex earlier?
You mean in terms of the reality of what happens?
Yes.
So the reality of what happens, there's depending on your story in your area.
I think you gender because of earlier physiological changes compared to male.
Okay. That's
or sexual behavior, testosterone-driven sexual behavior is different than oxytocin-driven sexual behavior, which might lead to the male sex
initiating earlier. Okay, so you have a plausible story for why the female sex should initiate earlier, and you have a plausible story for why the male sex should initiate earlier. All right, this is really great. This is a wonderful conversation. Do you see that this is where any research has to start, right?
I mean, there's literature to see what we already know.
Correct. Okay, so you both have stories about what the nature of the relationship should be, and now we have to find evidence for whether there is support for your story or your story. All right, but the important point here is that all of this starts with the story, the argument. There's a plausible argument over here and there's a plausible argument over here. I'm agnostic about which one is correct. It doesn't really matter. What matters is that the story is there and that the story has to be verified by data. Question.
I'm trying to get my head around this dependent dependence.
Yes.
Them to write
Yes, this left to right business.
So the independent is how X affects Y.
Correct.
So the way we're asking the question of which one is dependent and which one is independent, and how if we're looking at how one thing impacts on another thing.
Correct.
So in this case, we are looking at how sexual, biological sex, gender
Yes.
impacts on.
Correct. Correct. Exactly right. Now notice, I did not say what is the relationship between sexual initiation and gender. I didn't say that. Because that would be the other way around. And basically, it would be saying, is there a real plausible story that I could come up with for why the age at which somebody initiates sex affects gender? Is there a story there? Does that even make sense? It probably doesn't from a medical perspective. And so that's why one has to start with, does the story make sense, right? And again, this is really important. Any tool that you use, like JD and I use Stata, right? You may use SPSS. It really doesn't matter. Stata and SPSS are really dumb. They are not going to tell you what the independent variable is and what the dependent variable is. You have to tell you what that is. You have to come up with the story. So Stata can estimate any relationship you want it to, right? But the real question of what is the independent variable and what is the dependent variable is not a statistical one. It's a conceptual one. And you have to reason that out before you start, right? So this is a way of connecting everything back to how we started our conversation in the morning, all right? Clear? So now we're talking about the tool that we're going to use to do this is called a t-test, right? And there's a reason why we're going to use a t-test, and I'll talk about that in a second, right? But let's talk about gender. How is gender measured? What's the measurement level of gender? What's the first one? I don't know what that is. Yep. 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 Please go back. Somebody tell me. What's the measurement level of gender? What type of variable is it? Nominal and qualitative are both correct answers. All right. So it's a qualitative variable that is also nominal. The age at which people initiate sex is what type of variable? It's quantitative. Now, I thought that you told me that you weren't a statistician. You're doing very well. That's correct. All right. Now, this is really important, right? Because the measurement levels of these variables determine the type of tool that we use for assessing the relationship between gender and age at sexual initiation. But first, what type of data do you think we need to answer this question? Experimental data or observational? Why? Okay, yes, but why can't you use experimental data? What do you mean by that? Okay, what is already there? Not the relationship. Let's talk about the independent variable. You're almost there. It's this business of randomization. Is that load shedding? I'm so sorry for the folk that that are online.
Yeah, you just lost your.
That's fine. You guys have the
No, I'm just thinking in terms of because is your computer electricity dependent?
Yes, but my computer is fully charged.
Right, so the people online are still there.
Yes.
And we're still recording.
Okay, that's fine.
So we're all fine. It's just us and we've got the slides in front of us.
Yes.
Okay.
That's the backup. I had planned for that.
Yes, it's very well.
Thank you. All right, so again, why are we using observational data and not experimental data? And it has everything to do with the independent variable and matching. Remember, I used an example of experimental and control groups and how people ended up there. Is it? There are two types of groups here, male and female, right? And let's say that one group was the control group and the other group was the experimental group. Is there any plausible way that you could randomly assign people to maleness and femaleness, right? And for that reason, there is no experimental design possible, which is exactly what you said, right? What you said was that we just simply observe what is already there. We observe that people already have the characteristic of being male and being female, right? And so this means that we just use observational data. Moving to the next slide, right? Slide number 42. The data that I'm using is observational data from the demographic and health surveys, right? I'm just simply describing the data that I'm using to answer this question. The data, these are cross-sectional data, cross-sectional observational data that are collected every few years from a bunch of developing countries in the world, right? And I am using data from two countries, Lesotho and Eswatini, right? Lesotho had data collected in 2009 and 10 and 2014, and Eswatini had data collected in 2006 and 2007. Now, the reason I'm using these data is because they have very good data on the age at which people initiated sex. And of course, they've got really good observational gender data. Okay? Questions about that? So, moving on, next slide, slide number 43. Here's the steps to the analysis. I need to describe the data. I need to conduct a t-test. And I need to interpret the results. Okay, but let me stop here and say that we're using a t-test here for figuring out whether there are mean differences in age at sexual initiation between males and females. Again, one more time, we're going to take the mean age at sexual initiation for males, and we're going to take the mean age at sexual initiation for females, and we're going to compare those means to see if they are statistically different from each other. And that is what a t-test is. If there is a relationship between gender and sexual initiation, then we'll see a difference in those means. If not, we'll see no difference. All right, questions about that? Yes.
In terms of, do we need to worry about whether the distribution will be, so we can be guaranteed it'll be a normal distribution, or do we need to figure out whether the distribution might be skewed? Do we need to compare the median and the mean?
So, right, so there are ways of figuring, correcting for skewness in the age at sexual initiation, and I'll show you that, all right? However, there's one more thing that I need to tell you. Now, remember I said we're using observational data, right? And we're figuring out the relationship between gender and age at sexual initiation, right? Observational data, okay? Now, we're not using experimental data. What that means is that if we find a relationship between gender and age at sexual initiation using observational data, we still have to do what to establish that the relationship is real? Correct. We've got to control for a bunch of stuff, right? Now, if this were data that was coming out of a lab, there would be nothing to control for, because by design, things would be controlled for. But I'm just showing you the raw relationship between gender and age at sexual initiation using the tool of a t-test. What you need to know is that even though we may observe a relationship, that relationship may not be real because other things have not been controlled. I just need you to understand that. All right? Questions about that? So again, from slide number 43, the process that we're going to do, we're going to describe the data, we're going to conduct a t-test, and then we're going to interpret the results. Okay? So the first thing to do, slide number 44, moving ahead, is to describe the data. On slide number 44, notice that this is a frequency distribution of gender. Everybody see it? Can somebody interpret this distribution for me? The young woman in the red, who's peering at the notes so carefully. Yes, you. Can you describe the distribution of gender?
So out of 19,000, 6,600 males.
Okay, correct. Can you talk to me in terms of percentages? Are females, correct? Correct. All right, that's the distribution, right? Nothing to it, right? Easy. Next slide, slide number 45. Can somebody else interpret these statistics as they relate to the age at first sex or the age at sexual initiation? This is slide number 45. Somebody else, talk to me first about the skewness of the distribution. Is it skewed?
50th percentile, the median.
Mm-hmm.
Active birthday is 17 years.
Yes.
And the mean is also 17.6.
What do you conclude? Okay, correct.
Approaching.
Okay, everybody agree? All right, wonderful. All right, so this is the kind of thing that you would report in your article, right? You do this so that you're reporting the contours of the distribution for the reader, so that the reader can really understand what the actual distribution looks like. Okay. Step number 3 on slide number 46. Let us figure out whether there is a relationship between gender and sexual initiation. This is called a t-test. All right. Forget about the actual command. I want to walk you through the results. You've got a bunch of information here. All right. Look at the row that begins with females. Everybody see that? And the row of information that begins with males. Everybody see that? All right. So what is the mean of sexual initiation for females? Correct. Everybody see that? 17.56, correct? What's the mean of sexual initiation for males? 17.82. Everybody agree? We're all on the same page? What is the difference in those means? Okay, what does the minus mean?
Had a choice of which one depending on your original concept, I see, but you decided that female, for some reason you subtracted the males from the female, rather than the female from the male.
Go ahead.
It's negatively skewed.
That's not right. That has nothing to do with the distribution. The difference I'm talking about is the difference in the means.
There's a very small difference. The reason why it's negative is because you subtracted the females from the males, and that I don't know why you did that.
The computer just made a difference,
Okay.
made a distinction. All right, but everybody understands what that negative means. Who does not understand what that negative means? Okay, so that negative really is talking about the fact that sexual initiation for females is less than the average sexual initiation for males. Less than. Right? Notice that 17.56 is smaller than 17.82. Everybody see that? And that difference is negative 0.263. Now, is that a large difference or a small difference? It's a trick question, but I'm going to lead you in the right direction. First of all, let's talk about the actual difference. Is it a big difference in terms of numbers? Okay, it's a small numerical difference. Everybody agree? All right. Is the difference statistically meaningful? By that, I mean, everybody pay attention to me. If I were to repeat, if I were to sample from Lesotho and Eswatini over and over and over and over and over and over again, and every time I take a sample, a random sample from the population, I conduct this t-test. Every time I take a sample, I conduct this t-test. And every time I take the sample and conduct a t-test, I get an answer in terms of the difference in the means. And if every time I take that answer comes out to around negative 0.263, that means that the difference is statistically significant. Let me repeat that. If I sample over and over and over and over again, and every time I sample, I get an answer. And if that answer I get comes very close to negative 0.263, that means I'm getting the same answer over and over and over again in terms of the mean difference. That is telling me that the mean difference itself is statistically significant.
Might not be significant for your study. You might go, so from a medical, from a conceptual point of view,
Yes.
you might say this difference doesn't matter because it's around about 17 years old. But statistically, we know there is a few months difference between.
So we're talking about different things.
Exactly.
Right? So there's a difference in terms of the raw difference in the numbers, and then there's the difference in terms, and there's the statistical difference in terms of, is it meaningful? In other words, upon repeated sampling, do I get the same answer over and over again? So you could have a mean difference that is numerically small, but still statistically significant. And that is a very difficult concept to understand, but it's one that if you get it, you're going to be a star in South Africa. I guarantee it. Once more, the raw difference in means of age at sexual initiation is very small. It's about a quarter of a year. Everybody see that? But that difference is statistically significant. If you look at the bottom of the output, everybody see PR, and then it's got brackets, T less than T equals 0.000. If that number is less than 0.05, then that difference is statistically significant. And by statistically significant, I mean statistically meaningful. Upon repeated sampling, the likelihood that you would get something different is very small. Upon repeated sampling, the likelihood that you would get a different answer is very small. Once more, upon repeated sampling, the likelihood or the probability that you would get a different answer is very small. One more time for the road. The likelihood or the probability that upon repeated sampling, you get a different result is very small. And you want that probability to be very small because you want to be very sure that upon repeated sampling, you get the same answer, even though the mean difference itself is small or large or whatever it is.
I assume this is dependent on your sample size.
It is not dependent on the sample size.
But I mean, in terms of you won't be able to get this level of surety if you only look at 10 people.
Correct. So as long as the sample size is above, say, 30, we're okay. Yes.
Any study.
Yes, for any study. So that's my shorthand way of explaining a very complex topic, and it's called the central limit theorem. And just don't worry about it. As long as the sample size is above 30, you're in business. Now, this is a very big sample. Everybody see that? Thousands of cases, right? So it turns out that I'm okay. But I want everybody to be clear on what I mean by numerical difference and statistical difference. Yes. Correct. That's what it does. That is exactly what it is. That's exactly what it is. Yes. Yeah, you are a statistician, you just didn't know it, right? But again, notice I am framing this in terms of probability, and you just used the word p-value, right? That is what it is. It's a probability value or a p-value. It's talking about the probability that upon repeated sampling, you would get a different result. You want that probability to be very small. Right? So small that it is smaller than 0.05. You want that probability to be very small. Right? If you guys understand this, you will understand everything else in statistics, I guarantee it. Everything else. Everything else just simply riffs off of this. By riffs, that's like a jazz term, right? So it just riffs off of this idea of statistical significance and what that means. Let me stop and take some questions. JD.
I've got a question via WhatsApp from the online audience.
Yes.
And so there's a trend in medical literature
Mm-hmm.
to kind of move away from p-values and focus on 95% confidence.
Yes.
What do you think of that?
All right. Now, everybody look at the row that says DIFF. You see that negative 0.263? And then skip over the thing that says 0.045, that's the standard error. You see there are two numbers, negative 0.352 and negative 0.175. Everybody see that? That's called the confidence interval, right? In the medical literature, what they want you to do is report that confidence interval because they want to figure out the degree to which that mean difference sits between that confidence interval. Now, what JD is referring to is that in the medical literature, they want that confidence interval to be as narrow as possible. If it is narrow, that means that the estimate for the mean difference is very precise. If it's wide, then the estimate for that mean difference can sit in that interval that's very wide, and the estimate is not very precise. So in the medical literature, what they are forcing you to do is to really report or to hang your hat on narrow confidence intervals as opposed to p-values. They want narrow confidence intervals as opposed to p-values. Right? So that's why the person was asking that question. And that is why the medical literature is actually asking for confidence intervals, because everybody wants to report a p-value, but it's possible to report a p-value with a very wide confidence interval.
Stupid question.
There are none. No stupid questions.
This is how you relate that to standard deviation. Standard deviations you use to calculate confidence.
Yes, right. But I don't want you to worry too much about that. I want you to worry about how to use the confidence interval, right? Because the confidence interval is really a concept that is linked to precision of the estimate. Precision of the estimate. Notice that 0.263 sits in between a relatively narrow interval. That means that we're relatively, not only are we sure upon repeated sampling that we would get the same thing, but we would get the same thing within a narrow bound.
There'll be a real worry if one of those numbers is positive.
Yes, that means that if it was positive, we would be in trouble because it would be statistically insignificant.
Then the t-value.
It'd be very large. Yes, the t-value would be large.
T-value will be high.
Yes, and the p-value, right? I'm sorry, that's wrong. The t-value would be small, the p-value would be high,
Oh,
right? Small t, big P,
okay.
right? Yes. Confidence interval is really talking about the precision of an estimate, how precise it is. Yes, it means that you are 95% sure that that estimate lies in that interval. You're 95% sure. Now, if you wanted to be more sure, you could be 99% sure, but the standard is 95. Prof. Talway, did you have a question? None? Question? Cool. So these are, notice that the title of this slide, number 46, is results for both countries, right? We're looking at the relationship between gender and sexual initiation for both countries, Eswatini and Lesotho, right? But let's say we wanted to figure out what the relationship looked like for each country, not for both together. So I'm gonna, let's, slide number 47 looks at this relationship just for Eswatini, right? Notice that the sample sizes are different, okay? But what is the main difference between both countries together and and Eswatini separately? Can somebody interpret the difference? Here's a hint, look at the actual diff. What do you notice? Yes, yes. I'm trying to get you to compare the results for Eswatini to the results for all countries together. So on slide 47, you have the results pertaining to just Eswatini, right? And I'm asking you to interpret those results. What do they tell you? What language are they speaking to you? And I gave you a hint. Look at the difference in the means. What do you notice? Okay, what do you mean higher? There's a bigger difference. What does that tell you in words? How would you explain it to your next door neighbor? Let me help you out. When you look at all countries together, you notice a very small difference. But when you separate out the countries, first starting with Eswatini, what do you notice about Eswatini? And you can simply repeat the answer you gave me. Well, in Eswatini, the actual mean difference between males and females in terms of sexual initiation is large.
Yes.
Why might that be? Do you have I mean, I don't know the country. Do you guys have a qualitative kind of explanation for why that might be?
So basically, the women have sex a year and 3/4 earlier than men.
Mm-hmm. Yes. What might be going on in the country? Now, this is not a statistical question. This is really about, now can you bring your social and medical knowledge to explaining this result? This is about interpretation. Yes, yes. But I'm trying to get you now to step out of the statistics and into the role of now interpretation. You have to now paint a portrait of what these results mean. Okay? You've got to tell a story. So once you have results, right, you still have to tell the story. The story has to be dressed up. It has to, you have to give life to it. Okay? Now let me throw you a real curveball. Notice that the difference, notice the difference between Eswatini. Look at slide number 47 and move forward one, slide number 48. What do you see? Somebody else. Okay, okay. So in Lesotho, there's a positive difference, and in Eswatini, there's a negative difference. If you were writing this paper, what would you say about that? It's opposite, right? Now, I don't know why. It doesn't really matter why. I don't have to have an explanation. What this means is that if you were the researcher, you would have to have the explanation for that. And I think that if you were writing such a paper, it would be really cool to hazard a guess about what is going on within the country that would produce these differences. Now, the reason I picked these countries is because geographically, they are relatively landlocked countries within South Africa, right? And I want, as a sociologist, it's really interesting to me what drives differences like this, right? But what's important is that you guys notice that these differences are there, and then you put on your hats as medical researchers to actually explain what is going on.
The t-value, when you now talk about t, what is the word when you want to say the t-value is?
Okay, so there is,
It's one here, rather than also what is your-
right, so this is, the t-value is used to assess statistical significance.
you would say t-value shows that this is.
Yes, but usually people in the literature, people like you to talk about either p-values or confidence intervals. I've rarely ever see people talking in a method. Yes, it's just another way of assessing statistical significance. But if you're writing an article, you want to hang your hat on p-values or confidence intervals. All right. Anybody confused?
Why is there a t-value of 1 and then a t-value of 0?
Hold on one second.
So at the bottom there,
Yes.
the first calculation ends up on 1. I assume it's because it's still using the emails.
Okay, so are we talking about Lesotho or are we talking about Eswatini? All right. So the reason for that is that the actual difference, the direction of the relationship switched. No, notice that this young man said that we have a positive difference between males and females here, whereas before we had a negative difference. So the nature of the relationship switched. So you look at different numbers. Yes. There are two values for the confidence interval. So yeah, it's the technical term for this is an upper and lower bound. Right? So the one on the left is the lower bound and the one on the right is the upper bound. That, no, so let's be specific about this. Let's look at Lesotho. You are 95% confident that 0.476 lies between 0.368 and 0.584. Yes, the mean difference lies in that confidence interval. Right, so again, so let's look at the role for females. The role for females is the mean for females. It is a number, 17.74. There's a confidence interval for that mean. See that? The mean for males is 17.27. That is also a mean, and there is a 95% confidence interval for that mean. Is for the difference. And the t-test is all about the difference. Understand? Once more, the t-test is all about the difference. And there's also a confidence interval for that. The what? When you say the number of the t-test, what do you mean? Okay, so that t-test does say something. It is statistically significant if the t is larger than 2.4, I think. No, I'm sorry, not forget I said it. Larger than 1.96. It's specific for the for this type of test. Right? So 1.96 is the magic number for statistical significance. Just like 0.05, it's the magic number benchmark. Right? So anything larger than 1.96 is statistically significant. Anything smaller than 0.05 is statistically significant for p-values or probability values. More than 1.96, or go back please to slide number 47, right? Or small in absolute value, it needs to be smaller than negative 1.96, right? So 1.96 in absolute value. Notice that the t here is negative 22.14. It's a lot larger than negative 1.96. Everybody understand that? Everybody's clear about that? Sure. The benchmark for statistical significance, if you're using t, is the absolute value of 1.96. The absolute value of 1.96. So we have evidence for statistical significance on slide 47 because the t is larger than negative 1.96. You got that? You sure you got it?
Yeah, I think so. Just to make sure.
Yes.
The confidence interval.
Yes.
Precision of that estimate.
Yeah.
Was within the normal range for both of them.
What do you mean by the normal range?
So negative 1.7.
Yes.
And then negative, so that was the sequence 0.47. That is positive. So that was not. It wasn't within the confidence interval for the SO2, but it was within the normal range, so less than 1.96.
So you're mixing things up, all right? So the confidence interval, right, is an upper or lower bound, right, that should contain, right, the mean difference. Now, if you look at slide number 47.
On the slides, you see that t number. That's not helpful. So here's the t number. What's that mean?
It didn't print well on the copy. It didn't print well. Oh yeah. No, I didn't know that it didn't print well on the copy. I had no idea. But you're clear now? Good. Who is still unclear? Yes, Prof.
The benchmark.
The benchmark, yes.
The positive value of 1.86.
Yes,
So whatever is below
yes.
1.86 is going to have a statistical significance.
So let's be careful here. When we're talking about negative 1.96, we want a t-value that's larger than negative 1.96. You have to ask yourself, what is larger than negative 1.96? It's anything larger is larger in the negative direction, right? In the negative direction. If you're talking about positive 1.96, larger is something larger than 1.96. But you have to know which side you're on, right? That's what I meant by absolute value. Is that clear? Good, good, good. Any other clarifying questions? And a response of, David, I don't understand, is perfectly appropriate. Yes.
For example, on the research result, we see the positive difference of 0.47.
Yep.
If that T number there, that 8.6 was, let's just say 1.5.
Yes.
For example, then it would be a statistically insignificant.
Correct. Correct.
That would be reflected in the calculation.
Yes. It would be reflected. Here's what you would actually, let me answer that technically. Here's what you would see in terms of the confidence interval. One of the confidence intervals would be negative and one would be positive. That's what you would see.
When you look at the t-test, how do you read the values in the t-test? That's not the actual number that we are t minus 2.
Which t-test are you talking about?
Well, I assume at the bottom,
Yes.
the t-test includes all of this. So at the bottom there you have those calculations, P R bracket
Yes.
T minus T.
Yes.
What do you call that?
Okay, those are the p-values, but you have to know which one you're looking at. All right, so look at.
The t-test is just the t, that's an absolute value number.
Yes.
P-value is the calculation where you take the big T minus 40.
The p-value is the probability value that is calculated for you by the computer. Right? It is calculated for you. I definitely see your hand. But you're clear? Go ahead. Oh, no, don't apologize. Go ahead. Yes. Yes. I thought you weren't a statistician. That is exactly what it is.
The critical value, is that the same study?
Yes.
Okay, so it's not specific.
No.
Value. Okay.
Yes.
1.96.
Yes. Think 1.96 as the benchmark or critical value. Got it. Right now, remember, it's 1,96 in absolute value. In absolute value. All right, everybody's clear about this? I just want this to sink in, right, before we move on. Now, I've thrown a lot at you, right? You're talking about relationships between variables, and then you're talking about how to assess those relationships in terms of statistical evidence. There's a lot here going on, right? To do this, and I've thrown at you this business of confidence intervals and stuff like that, but they all fit together, all right? Questions? All right, wonderful. Let me move on to assessing relationships